This is part 2 of a video that is designed to help you to tap straight holes. Now we're going to tap these on the drill press by hand. We're going to drill under power, then we're going to turn it off and tap by hand, and this will ensure that the hole that you tap is perfectly in alignment with the hole that you have just drilled. But you must do it all in one step without moving the work or moving the vise. So we're going to have the vise clamped down for this. This is something that we've probably covered in some other videos, but we're going to go over it again. And we're at the Walker Turner drill press now, and I've got some hot rolled steel, which doesn't tap very well, by the way, but it's cheap. So it's my demonstration piece, and I'm going to drill it 13/64, and then while it's still set up, I'm going to install a little center here, and then we're going to tap it with this tap wrench, and it's 1/4 Now you got to make sure you have enough space here between the work and the chuck and the center that we're going to put in there to complete this operation without moving anything. So the table is dropped a little farther than what I normally like to drop it. So let's drill that hole. There we go, and that was at the end of the travel. I've got 4 inches of travel on this drill press, which isn't, that's probably about average, but the other drill press I got here, Rockwell, is 6-inch travel. I made this little center years ago. I suppose I made it, I ground it on the lathe, I guess. It was so long ago. But you can make one on the lathe if you can't buy one. Now just snug it in there, it doesn't need to be very tight. The end of your tap wrench has a little hole in it, and we're going to use that for alignment. Bring that down, and we'll put a little bit of tapping fluid on there. Now that's going to hold it perfectly in line. I'm tapping with my left hand, and I'm holding the quill of the drill press down in contact with the work with my right hand. And continue until you're all the way through. This is a plug tap, not a taper tap. It's not so terribly important to have a taper tap now because we cannot go crooked with this type of setup. Now here's a variation of what I just showed you. Some taps have center holes. That's the one that I just used. Others are tapered on the end here, and there's another way of holding those. And I have another spring-loaded tool here. See how that's spring-loaded? That has like a little center hole in it, and we can guide our taps with that as well. So I'm going to finish off the hole using this method, which really is just a variation. It's almost not worth showing you, but only the smaller taps will be built like this. The bigger ones are all going to have a center hole. Okay, we're going to finish off the same hole, which I know I've been tapping on it for a long time, but for demonstration purposes this is just fine. Now I've used the other spring-loaded center on a different tap, the tap that is tapered on the top, and you can use a tap wrench or a little adjustable wrench. Here I'll use my little crescent wrench, and again we're being guided by the spring-loaded center. And that works real well. However, you have to drill and tap your hole and then relocate and drill and tap the next one. You don't want to remove the work. Now on something like this isn't very important. But if you're tapping a casting or some other expensive piece, and I still have holes to drill here, I've got 6 holes. This is a steam engine cylinder, and I don't want to spoil the piece, so I'm going to do that by this method, so I tap nice and straight. Now this method can be done on the milling machine, the Bridgeport, as well as the drill press. Many of you don't have a milling machine, but this is can be done on either, and it's a hand operation. We're not doing it under power. Just a moment of levity here before we get on with a very serious subject of tapping, but the Joker is standing here with that fiendish grin on his face, holding a little tap wrench, getting ready to work. But the reason he's laughing at you is because we're going to have a little test now, and I'm going to ask you what a mystery tool is, and we'll see if anybody can identify it. I wish I had the character called the Riddler rather than the Joker, because this is kind of a riddle. The Joker is wondering if anyone in our audience can identify this tap. It's about 8 inches long. This is metric, although that's irrelevant. But the end is shaped like a candy cane. And the only hint that I'm going to give you is that this was used in manufacturing. It's not something that you would use at home. It's not a tap that you would use at home, but it is an 8mm tap. And we're going to let those of you out in radio land determine what it is, and if you have a good guess, put it in the comments, and then we'll let people bounce off of that to see if we get any results. I am never going to tell you the answer. It's going to be up to those of you that are watching this. So see if you can wipe the smirk off the Joker's face. Here's yet another method. We'll call this the poor man's method, because you don't really need any tap wrenches or any gadgets or accessories to do this. But I've got the tap. The hole is drilled. We're going to finish tapping. I know I've been finished tapping on this hole for a long time, but we've got the tap in the chuck tightened up, and we're just going to use a piece of 5/16 rod that will fit into the chuck. Now you can also use your chuck key. Just stick your chuck key in there and use it as a handle, because we're just going to turn this by hand. Or here's a slightly longer piece of rod if you need some leverage, but for our purposes here we'll use this short piece of 5/16 material in the hole, and you need both hands because we're going to bring that down, and then we're simply going to tap it like this. My right hand is on the down feed of the drill press. That's a good method too. Remember, it's sometimes hard to get the tap real tight in the chuck, because the tap is hard and the chuck jaws are hard, and there's a tendency for it to slip. But this poor man's method is also pretty good, because it will hold you in alignment. Here's another tap wrench. I don't know where I got it. It says made in Germany, but it appears to be of inferior quality because the chrome is peeling off of it. But there's no handle on it, so we're going to hold this, which I'll call a pilot, directly in the chuck. Now you could make one of these, especially if you have as many tap wrenches as I have, by pulling the handle out, throwing it away, and putting it on the lathe and drilling and reaming a hole and put a little pilot in there, if that would be of any use. The only problem with this is the whole doggone thing is so long that I have to drop the drill press table down considerably to accommodate it. So let's stick that in the drill press and take a look at it. The tap wrench is now installed in the chuck. Continuing to tap the same hole. You'd think that stock was 3 inches thick instead of 3/8, as long as I've been tapping on it. And again, just a little 5/16 rod that'll fit in the chuck. And we'll have to hold on to the drill press quill feed now as we do that, and we would tap. So that's yet another method of doing it, just a variation. There are probably many other methods as well, but these are the methods that I use in my model building where I want straight holes. Just a quick review on what taps are made of. Normally, if you go to the box store again and talk to the tattooed girl, or you go to Ace Hardware and you talk to the woman with a mustache, they're just going to hand you a tap. They don't know what it's made out of. But the cheaper taps you're going to find on a hook in a store are going to be made of carbon steel. If it does not say HS on it or HSS for high-speed steel, then it's not high-speed steel. However, these carbon steel taps are made in USA, so that's been around, but the manufacturer's name is not on there, nor is the material that it's made of. So that would be a carbon steel tap. It will be adequate, but if you're going to tap thousands of holes, it's going to get dull. Now, when the taps get dull, there's a greater likelihood of breaking them. Now, you will need to buy your high-speed taps from an industrial supplier. I don't think you're going to find them locally, unless you have a store like Ranger's or McMaster Car where you can walk in. But here's a tap. That's not going to show up, I don't believe, but it says 5/811 National Course, HSS for high-speed steel. Oh, isn't that beautiful? US of A. But try to get the high-speed taps. Now, if you run into a dull tap, throw it away immediately. Do not put it back in your drawer because you will forget that it's dull by the next time you need that tap size. And it needs to be discarded. You cannot sharpen them. I know it breaks your heart to throw away something that you paid $10 for, but you are wise to throw it away. Here's a surefire method for tapping straight holes, but most of you will probably not have one of these, but this is a tapping head, automatic reversing, Procunior brand, which is my favorite. I guess it's my favorite because it's the only one I got, and I bought it used, and I only have collets to hold 1024 or 1032 taps, so that's the size we're going to tap. But I'm on my Rockwell drill press now, and I don't really like this machine because it's so doggone loud because it has the variable speed. But it does have a 6-inch stroke. That is a big advantage. So we're going to tap some 1/8-inch thick aluminum. I've already drilled some holes in there, 13/64 holes. And I have shown this on another video that is dedicated to the tapping head, and some of you have watched this, but and you can go back and watch that again if you're a newcomer. But I want to show you how this works real quick again, and then I'm going to show you a poor man's power tapping head. Again, we're tapping under power now, and it's automatic reversing. So let's take a look at this. We'll tap this row of holes, which I have drilled 5/30 seconds. The other holes here are reserved for the poor man's tapping head. So we'll put a little bit of aluminum cutting fluid on there. Now this will be so loud you won't be able to hear me. Now those holes are tapped perfectly straight. Notice that I was able to stop and reverse it, or even go back into the hole. That's what I was showing you there. and a little deburring there, and those holes would be ready to use. So the Procunior or a Tapmatic makes one also that is these are really nice heads, and I was running the drill press at the lowest speed, which is 400 I believe. So that's one way of doing it if you got one, and it's really fast. By the by, these are called machine taps that I'm using in the Procunior. Spiral point, we used to call them a gun tap because it shoots the chip ahead, and they're not designed for blind holes, they're for holes that go through. But that's a spiral point or a gun tap, and that's also what I'm going to use in the poor man's tapping attachment. So here's the poor man's Procunior, designed and built by my brother in Cody, Wyoming, and you say, well, that's just a piece of brass with a hole in it. But it's a little more complicated than that, but yet it's really very simple. This will hold only quarter 20 taps, but there's a piece of round brass about 1/2 inch diameter, 1/4 inch hole, but at the point right there it has been broached 3/16 square, so we've got a square hole inside, and then on this end there's a magnet. Now the magnet is holding the tap in so it won't fall out. Just a little round magnet similar to one of these, only must be smaller, but these are incredibly powerful magnets, so powerful I can't let my grandkids play with them because they pinch their fingers and cry. But we're going to put this in the drill chuck and tap, and what happened, under power, and when I stop feeding, when I get all the way through the work and I stop feeding, what will happen is this will pull out from the magnet and stop driving, and it'll be a perfectly straight tapped hole. The disadvantage of the poor man's tapping device is you have to back the tap out by hand. Let's give this a try. You cannot buy these, you will have to make it, should you want one, which I doubt you will. By the way, when you're tapping aluminum, make sure you use the appropriate one for aluminum. Do not use the regular Tapmagic or Mystic Metal Mover unless it's made for aluminum. And someplace on here it says all metals except aluminum. If you violate that little line there, you're in for a big chemical surprise. But these products work very good, with the exception of, I'd like to know who the brilliant engineer was who decided to make this smell like cinnamon, because it gets on your hands and then it's there all day, and if you don't wipe your mustache with your hand, or you're in for another little unpleasantry. But it's a good product except for the smell. Why do they do that? I will not tap all the way down to the end because I suppose there would be the chance of breaking the tap off, but I'm just going to tap about halfway, and then I'm going to back the quill out, which will release the tap from the magnet. Here we go. I already put some cutting fluid on there. And there it is. It drove it in that quickly. The disadvantage, of course, is that you got to back this out. My brother made this cheap little plastic deal to back it out, but you could back it out with your hand or a tap wrench or whatever. Notice how the chip, I told you this was sometimes called a gun tap because it would shoot. I think that's why they call it. It would shoot the chip out. I just knocked it off, but there was a chip on the back side. The beauty of this and the Procunior is that you're able to float your work around to where you want it. You don't have to use a vise. Now let's do another one, and then stop your video and reverse it and play it back several times to see how this works. But this is pretty nifty, really. But my brother is pretty inventive. He can think out of the box. There we go. Slow speed. You simply back it out and that releases it. Pretty slick, huh? Now when I use the poor man's tapping head, I'm setting the quill stop at the point such that the tap will not go any farther down than this. At that point the tap will pull itself out of the work, or out of the holder rather, before it can break the tap. Just in case you aren't alert, let's say you're doing thousands of these holes. So let's drill just, or tap just one hole, showing you that. You see it stopped tapping before I backed it out. So that's the safety feature of the poor man's tapping head. Quite a few features for something so simple, don't you agree? That concludes this video. I hope that helped you. You got some ideas how to tap straight hole. Now there are probably other methods as well, and there's always somebody that emails me right away and say, why didn't you do this or why didn't you do that? Well, I didn't do it because I didn't think of it, and some of you guys probably got some pretty good ideas too. And if you do, go ahead and make a video, and then you can get permission from me, and the video will be attached onto mine, however YouTube does it. But it's then the other method can be viewed also and shared with other machinists. Hope you enjoyed this. This is tubalcain saying so long for today.